Okay, guys, today we are going to learn about density. All right, so density is might be a new term to you. I don't know. You might have seen it before, but it's new this year. But density is pretty much it's how packed an object is. A lot of you guys have thought about like density of an ice cube or ice. It's one of the only states of matter that as a solid state it floats in its liquid state. So that's why a lot of things freeze from the top to the bottom, because if things froze from the bottom to the top, there'd be a lot of dead fish in the world. Or I guess they wouldn't be in the world. But anyways, moving on. Something that you will see a lot, you will have this this formula. Density is mass per unit volume. The word per, if you ever see that in here, per always means to divide. It means to divide. So on this first one, make sure that we are going to use our units here. So I know I'm normally not picky here, but we are going to use our units as we put this out. So a rock has a mass of 15 grams and a volume of 5 cubic centimeters. What is the density of the rock? So all we're going to do is plug in what we know into our formulas. So if density equals mass over volume, mass per unit volume, I am solving for density, so I'm going to have D equals my mass, which is 15 grams, over my volume, which is 5 centimeters cubed. So all you have to do is divide those, and then this would be 3, and then your units, since nothing crosses out here, you have grams on the top. It's called grams per cubic centimeters is how you would read that. So a lot of density problems have 2 units for that. Okay, go ahead and try the next one. Okay, you should get 0.8 grams per cubic centimeters. Again, the mass is on the top, so it's mass of 8 grams. You're just dividing 8 over 10, which would be 0.8 grams per cubic centimeters. Go ahead and try number 3. Okay, for this next one, if you actually look at the question, it's how it will be phrased a lot. So whenever you get confused, if it says grams per milliliter, you would just take and divide the grams over the milliliters, whatever you see, because per means divide, grams over milliliters. So again, 40.5 grams, 15 milliliters, you divide them, you should get 2.7 grams per milliliter. Okay. For the next one now, it's asking what is the mass of ethyl alcohol. Exactly fills 200 milliliter container. This is your volume. If the density is 0.789 grams per milliliter. So this is going to look a little bit different. If I have density equals mass over volume, guys, you're still going to just plug in what you know. That's it. Okay. Now it gives me the density, so I'm going to plug this in for density. You have 0.789 grams per milliliter. Okay. Equals my mass, which I don't know, over 200 milliliters. Now from here, I could probably do something that we've always known and loved. Cross multiply if we need to. So when I do this, I have M equals 1 times M is M. Then I'm going to multiply 0.789 times, which is grams per milliliters, grams over milliliters, times 200 milliliters. And if you notice, the reason why this happens now is whenever we multiply these two, see how this is the denominator? These guys will actually, the units will actually cancel out. And so my answer should be in grams, because grams would be what's left over. If I multiply those guys out, I should get 157.8 grams. Okay, so set up the same way, same formula, only we may have different unknowns, and we might have to cross multiply a little bit. Okay, if we look at the next one, you guys can move on if you want. If you want to pause me and go try these on your own, you can do that. A rectangular block of copper weighs 1896 grams. Dimensions. Oh, it gives us dimensions here. 8.4 times 5.5, 4.6 centimeters from this. What is the density? So density, it is asking for density. I'd maybe circle what it's asking for, equals mass over volume. However, it makes it so we have to calculate our volume. Can you guys tell me how to find the volume, or what is the volume of that block? Or another way is just your generic prism, like a Kleenex box or something like that. Okay, you would end up multiplying all those together times 5.5 times 4.6. All those are centimeters. And when you multiply those together, you should get something like 212.52, but we can just go 5, that's fine. And that is centimeters cubed. All right, so we're just going to plug that in for the volume. We're going to plug in the mass, and then you're going to tell me what you get. All right, so you should get 8.9 grams per centimeters cubed. So what I'm going to have you do is try the next 3 and put in your answers. So I'll just do one at a time, but go ahead and try number 6. Okay, when you plug this in, you are solving for the mass. So you should have m in the numerator. And when you do that, when you cross multiply, so mass is in the numerator, you multiply those two numbers together, you should get 219.1 grams. Okay, go ahead and try number 7. Keep in mind it is asking for volume, so it might be a little different. Okay, when you do this, volume's on the bottom, so then when we cross multiply, we get 2,500 times 1, which is 2,500. We get that over here, times 10.5 times V. So I brought the units here too, that way you could see, if you notice, whenever we multiply here, we have to divide both sides by 105. It's the only thing that's different. And if you notice, these grams actually cross out, so that's why I'm left with V equals that number, 238.1, and then centimeters cubed is left. Okay, so we will go ahead and try the last one. One last one, we're trying to find the volume of the liquid. It gives us the density and the mass, so we're plugging that in, cross multiplying. Again, the word per would mean divide. We will see that more a little bit in the future here, but you should get 11.9 milliliters for your volume whenever you cross multiply. And that's it.